So I'm logged into GitHub. I have a code space. So to open a code space, you click on code spaces. I've created a code space here. And in this code space, I have the sample app MicroProfile e-commerce application. This is a microservices based application. So the code space is loading. So in the meantime, we'll discuss about MicroProfile. So before I start with the application, I'll give you some background. So the example which is shown is part of official MicroProfile tutorial, and this will cover all the specifications. MicroProfile is an open source specification which is for optimizing enterprise Java for microservices architecture. This was created in 2016, and at that time Java EE community was facing a challenge that there was less innovation happening, and MicroProfile was incepted to bridge the gap between Java EE, and it was aimed to introduce features which were specifically designed for microservices development. Later, Java EE was rebranded to Jakarta EE, and in this tutorial, we'll demonstrate a real-world project, and we'll demonstrate various microservices-based specifications from MicroProfile, and we'll share you good insights about what all is required for building cloud native Java applications. Definitely the prerequisite for this session is you should be familiar with Java platform. If you're not familiar, then you may look into Java development platform. You can learn Java from the link dev.java/learn. So let me share. If you are not familiar with Java, you can learn it at this particular location. This has good tutorials and content for getting started with Java. You will get everything around Java, and you will get a playground to write your code and test it. So this is very convenient. In browser, you can run your application, test Java, and also you can learn various topics about Java. So we will be using design first approach. We will be building an e-commerce application, which will be a very good example for microservice based cloud native applications. We will first design the APIs. I have used here Swagger Hub to define the APIs. So let me talk about what is the project all about. So first I'm logging into Swagger Hub. Swagger Hub is located swagger.io/tools. We'll learn more about Swagger in the chapter about MicroProfile OpenAPI. So as you see, this is my microservices application. It has various microservices. We will be writing more, and we will be writing as per the specification which I have provided here. So I have used OpenAPI 3.1, and in this first few sections about description, title, some metadata which is about the GitHub URL of examples, and some housekeeping stuff. The real definition of APIs starts from here, which is will be defining endpoints. So we have a microservice which will be calling catalog or product catalog. This will have products, get product functionality, which will list all products. Then we have other functionality. So you can find everything related to the microservices API in this particular Swagger Hub page. I'll be sharing the link. So you start by defining the schemas for the data objects as well as the APIs for your microservices. And then I have implemented it. I have used an architecture pattern here where I am taking care of splitting the functionality into various packages. So we'll be discussing more about this. So yes, we start with an application which is just a configuration which defines the base URL for this particular microservice. Next, we define the endpoint REST resource. In this REST resource, if you see here, we have a resource, and then we will define a product service. So here we have a product service which is injected using CDI. We have the base URL products. And then we have various details. We have used annotations for defining the OpenAPI documentation. So let me look into this product API. So here we will be defining a service. So service will be called product service. It is defined in IO MicroProfile tutorial, store, product, and service. And just checking here if the package is properly defined. IO MicroProfile tutorial, store, product, then service, and then product service. So we got this defined twice. I'll remove this. And this class will contain various methods. So first method is, we'll have methods to find all products. So my service should be calling the repository, product repository, and it has method get products. So here the resource should be calling the service. So the get method should be replaced. So first we will check for maintenance mode. This is from the configuration. I'll be covering this in coming chapters. This part is all about getting all the products. So here we can simply say, here we are trying to find all products. So this logic we can move to the service class. So list get products. here is the repository and find products. Right, so I've got this defined. Then find product by ID. So this will be replaced by the corresponding method, which is called get product. And then I have update product. Update product will be replaced by method update product. So here it does not return any product. And if I go to the repository, update product is returning a product. So we can just change this accordingly. So here in the product service, I will say it will return product, and I will here return the product. Now I have the last. This is about delete product. And again, I have to see what is the delete product doing. Delete product should return again the product. If I see in the repository, it returns a response. So this response should be, so delete product is expected to return a product. And if I look into the repository, delete product is not returning any object, right? So this can be modified accordingly. So here if product is not equal to null, so here delete. So we don't want to we simply call product service dot delete product with the ID passed. But yes, before we delete, here we are doing this, we need to find the product. So find product by ID, and then I return this product. So it could be get product. With ID. Now this method is implemented. So we have got rid of all the modifications to product resource. This is the service method. Service method is simply deleting the product. So it could be of type void. So now all the errors are fixed. And if I go through the overall design of the product, we will have a catalog service, we'll have an inventory service, we will have payment service, We will have user management service. We will have the cart, shopping cart service. We will have order management service. So there will be multiple microservices. We will also have shipping request service. So overall, we will have 7 projects which will be different microservices. Coming to describing the architecture, so I have used a package structure. I'm just briefly describing the package structure. So I'm having data transfer objects. This will be for the UI. We'll begin with the entity objects. We'll add data transfer objects in case required. But yes, most probably will not be using the data transfer objects. We will be good with entity objects. Then we have these entity objects are basically the ORM objects. Then we have the repository objects. Then we have resources. Resources is the RESTful APIs. And then we have config package. We will also need health package. So we'll be defining health checks as well, briefly, shortly. So let's try to compile and run this application. I'll just briefly look into the pom.xml. So you see I have used the packaging type var. This is required for running this in the Open Liberty platform. I've used Java 21, the latest edition. I've used the port 5050. Catalog is the artifact. Let's use this as the context root as well. We may use different context root in different services and different ports in different microservices. So now coming back to the catalog, we have different ports defined. We have Lombok project, we have Java APIs, we have Java EE, JUnit, and Apache Derby database. And then we have the Liberty plugin to run these services. Next important thing is we can look into src main liberty server.xml. In this, various features are enabled. Definitely we need RESTful web service, we need JSON binding and parsing, we need CDI, persistence, OpenAPI for documentation purpose. So I will go to CD catalog package, which is the project package. Now next thing what I will do is I'll just do a mvn clean, because we will build this product, build this microservice, and then I will say mvn liberty dev to run this microservice in the debugging mode or development mode. So here all the features are installed in the Open Liberty. And now it's saying web application is available. So OpenAPI UI is also available. So no errors have been reported. Everything is clean, only info messages. Now I go to the port 5050, which is defined for the microservice. This is the home page of the Open Liberty. We have this catalog is the endpoint. We will have products as one of the microservice, which will list all the products. So if I run, I should not see any products as of now. Yes, so we also defined even before, we have the API as endpoint, right? And catalog products. So this is the path to the service. If I go to Codespace, let me look into if there is some error. So products path is not found. So as I say that there's a catalog.var, which is the name of the var, app root context. This is basically the artifact ID as well. So catalog is the artifact ID, var, and that's also the name of the context. So yes, I think this context will come first, then the API, and then products. So no products found. Yeah. So now we have hit the right endpoint. Next is we should look into the Swagger, because that will be the easier way to execute these APIs. So I will say Open API. When I just give this will show me the metadata about the APIs, which is defined for catalog microservice. and if I say /UI, I'll get the Swagger UI. So list all products we just executed. This is a get service, so could be executed with the help of browser. Let's now create a product. So we'll say try it out. I'll create a product 1. I'll say this product is iPhone 14, and I will say here the description Apple iPhone 14 Plus, price is $699. I will execute this to create a product. When I execute, I got a response, new product created. So this is very simple to execute through Swagger API. Now just to verify, I will call the get product again. And you see here when I say try it out and execute, I should get the array of products, and right now I have one product. Let me add another product. So in this, let me put the ID 2. Product is iPhone 15. I say Pro, and I will also accordingly add the description and pricing also, $899. Executing it. Again, a new product has been created. Now if I execute this get API for all products, I should see 2 products. And this is the case. I am seeing both the products, iPhone 14 Plus, iPhone 15 Pro. So here I will also update the name to iPhone 14 Plus instead of iPhone 14. So let me do this with the help of Put API. So I go to the Put API. I am looking to modify my item. So I'm just trying it out. In the documentation itself, my ID is 1 iPhone 14 Plus, and then I say Apple iPhone 14 Plus. I'll update slightly the price just to demonstrate that multiple fields can be updated here. And then when I say execute, it says put is executed and product is updated. We get this curl command also, which you can try it out in terminal. And the product is updated. And if I run the get methods, you will see that these products have been updated. So we have tried various APIs. Let me try this get product by ID. And here we got a form, and I will put say product 2, which is iPhone 15 Pro. When I run this, I see the description. Similarly, I can also see the other item 1. So this is also updated description about the item. Now next thing is the delete API. So if I want to delete first item, I go here, enter ID 1, and I execute. Now the first item should be deleted. So here I'm getting entity must be managed to call remove, and try merging the detached. Okay, so the merge call has to be there. So I'm coming to the service microservice code to see if we can fix this error. I have the product. In the product service, we have here the update product function from repository, and this is merged. Delete is remove. Okay, so basically here there's some suggestion. So if there is a product, so what I can do is I can try to merge this first and then remove it. Now product is deleted. So let me try to get the explanation why this is required. So here so yes, here is the explanation. So here that the merge ensures the product instance is managed even if it was detached before. So here we update it, and so that's the reason we have to use this code. So now all the CRUD methods are implemented for the product microservice. So this code overall demonstrate the implementation of microservices using Jakarta EE RESTful Web Service CDI. So we have used JPA from Jakarta EE. We have used CDI. We have used the core Jakarta EE10 core features, which provided CDI, which provided JSON binding, which provided RESTful web services. So in the same manner, we can implement payment service, inventory service, and we can implement other services as well, which is the shopping cart, order service. We can run them in different ports. See here, payment service I am running in 9080. Inventory service I can run in 8080, or maybe say 5050 is there, then I can say 6060. Like that, I can choose different ports. Or I can choose 5010, 5020, 5030, 5040, 5050. Like that, I can choose. That will be more convenient and easy to remember. Only thing is that ports needs to be separate. So you can see the full description about product microservices. And I have also shared detailed steps about how to implement OpenAPI documentation and how to use the Swagger UI in the chapters. So chapter 4 has these details about how to use various features of OpenAPI. Now let me look into the MicroProfile configuration. So MicroProfile configuration is a standard or a specification which is used to externalize configuration. So we have a payment module here. In payment module, we are not using any database. I am using the configuration, which is an external file. So here we will have various classes. My entity class is just a data object. It is not the entity class in this case. So I better will rename it to DTO, because this is something which is mapped to the data transaction object and may not be an entity object. Or I can name it as model, because this is just a model. It's not an entity. So But yes, we that packaging name does not matter much, but what matters is we have card number, card holder name, expiration date, security code, amount, all these details available. Then we should have a service class. So basically this is the service class. This we can call it as a resource class because this is basically resources which is being used, because service class will have just the business logic. So let me rename this. And I'll rename this to product resource because it defines the REST resource, which is the payment resource. And we say authorize is the endpoint. So I will go to, so we have the Swagger documentation for this also. So now we are done with the product catalog service. I will close this. So it is, the service is stopped. Now let me move to the project, which is the payment project. So payment project is also running well. I will just do an MVN clean on this, and then I will say MVN Liberty dev to run this in the dev mode. So here we have added various features. We would need the config feature as well. And you see here this config is added here. So in the payment, and yeah, let me close all the files. So here I have the server XML, and this server XML is from the payment module. Somehow it automatically added the config feature. I should have added here the config in the Liberty as well. And just verifying the version. Config 3.1 would be the latest one. So I've specified this. And I will also look into the pom.xml. It's saying it's not available, so maybe I have to update the Liberty version. So here I'm using 21 Java version, MicroProfile 6.1, Liberty Tools 3.10.1, so this is about POM XML. So I'm verifying because we are working on MicroProfile 6.1. This should support 3.1. So let me quit and then let's try running it again. So maybe I will do an ambient clean and then try again with 3.1. Right, so now we have got the features installed. No errors as of now. And service is running. So here we have the payment REST application. I will rename this to payment REST application. I will say rename. So right now it's just the API as the base URL. Maybe to make it more specific, I give this as a base URL. And then from the remaining section, I can remove. So for example, the resource part, I have authorize. So basically my context is, my context root is there. So yes, I can keep it like this. API, then server. Now context root will be defined in the POM, which is payment. And that's my artifact ID as well. And this should also appear payment.var. Right, so this is running, and let's look into the Swagger UI for this. This is running in port 9080. So I will launch this. This is also 50/50. Let me run it. And then I say OpenAPI. So I see the Swagger. I have an authorize method. So I will say UI. So I got this process payment. So here I have a payment service config source, which contains the gateway API and secret API secret and the gateway endpoint. So I've defined here a custom configuration, and this is within, so I have to create a file which is metainf services config source. Then I have a payment details entity. We have the payment config source. So here you see the secret API key is added as default. So maybe I will name it as default API key. And default is paymentgateway.com. And let's say we're putting this property, and this is hard-coded value, but actually it could be reading from that file. So which is so basically we could be reading from any file. So here I'm just putting it as a hard-coded value. It could be reading from any other source as well. So here API, and this is the gateway, and let me make it as in the resource default API, and I would say default API .paymentgateway.com. So now let me try executing it. So basically it's API authorize, no parameters required. No, it's required because you need to put all the card details. So let's say we have some card number, which is a dummy card number. Our API is also dummy. I put the name of the card holder. Then you have some expiration, let's say and then security code, and then the amount maybe $100. So can have some digits. Yeah, these are not my real details. I execute this. Payment process successfully. This is the response body, and I should see some log message as well. So here you see I am getting this information from the not the default configuration with my file, which is the class file, and secret key is also coming here. So let me just fix this spacing. So this is my payment resource application. Yeah, here one space would be readed. This is updated. Let me make another payment. this time of 200. Amount, I execute it. In payment process successfully, and here I should see the message. Yes, this is great. So this is about the payment microservice, which is processing the payment. In the same way, we can configure the databases, we can configure anything which is something which can be read from the configuration file, and we don't have to recompile the code to apply new configurations. Now we'll look into MicroProfile health. Let's implement the health for catalog microservice, and then we can implement similarly the health APIs for other microservices also. So we can also implement it for payment microservice as well. We can even try to implement the caching also for some of our microservices. So let's think about implementing health checks. Health checks are some mechanisms to add add observability. Basically, we define some endpoints through which we can expose health information, and by health of a microservice we mean whether it is in a state to serve the request. So the health of a microservice could be of three different types. There could be various types of health checks. One is the startup check, the readiness check, and liveness check. A service may be live but may not be ready because the initialization might be going on. And startup check is check which makes sure the service is running in. So readiness check is something which makes sure that everything which is required to run a microservice is there. So initialization has happened successfully. So let's make this for catalog service, because there's a lot of things which we can check in the catalog service. I'll come back to catalog service again, and yes, some test cases have not been used here, so I can say quick fix, remove all unused test cases. Okay, so here we'll define another package, and we'll define a class Let's call this class database health checker. Or let's check for the memory of the microservice. So let me create a package. So within product, we'll have a new folder which will be for health checks. I'll call it health. And in this, I will create a Java file which is product service health check. So this will give the name of the health check and should be a Java method. So I'll rename it to .java. Yes. So now I have package which is io.microprofile. This. Now next thing is I have to import some packages. One is, I'll say public class, and I will say this will implement the interface for health check, and I need to import the health check as well. So I import org eclipse microprofile health and health check. So product service health check. And I have to implement the methods. And there is a health check response here, which I have to call. And call method will be the method which will return the health check. So we need to implement this call method. So the way we can implement is So yes, let me also modify the POM XML first before I start implementing it, because this dependency is important here. We might have added MicroProfile 6.1. In case you want to individually add the health, then we can add the health. Right, so we have MicroProfile 6.1 altogether, so no need to add health. We'll have to add health in the main and then server.xml of the Open Liberty configuration. So here health is not there, so let me add the feature for health, and this will be health is 4.0. Right, so I got the health 4. Now to check for the database, I'll implement now we can remove this code because we will be going to implement this. So there's a health check, and one health check is database connectivity, is database connection healthy. Okay, something like this, right? And there could be a method here. So here I'll implement this. And how do I implement this is just having a method here, and it should return boolean. It should be a private method because I'm only calling here, and in this should return value, and it's not hard coded. Let's return the real value. So I'll also inject here the repository object. Repository, product repository, and now I have to use the product repository dot, I'll say entity manager, then say create query. I can say select one, get single result, and this code could be okay. So we might have to modify the repository. So here its entity manager is private. So we may define a get entity manager method. . So here I will say return entity manager. So public method em and return em. Yes. So now if I go to the service health check, I will execute this, and within the try catch I will just put some request here, lightweight query. This has to be lightweight because otherwise if there are performance implications, then health check and I say catch and say any exception, we may print this exception and return false. Okay, so good to print. Correct. So this is our database connection. And this check we can make it as, this is a readiness check. And this can be of application scope. Right. So now we have added the health. Now let me run this. I'm checking the MP health. Feature for Open Liberty. It should be called 4.0. So now the application is running. So here our context root is API, but yes, the health is coming from MicroProfile, so don't need the context root. So if I go to health, this will be an endpoint. So it says down. And then I say live. Liveness is up. Ready is down. Started is up. So now I'll go to the payment service. Okay. So yes, I'm getting database connection is not healthy. So here I would say, why not to use it request scoped. Rather than application scoped. Now I have updated it. So health is started. Then I have ready. What if I call this method within the product repository? And this should be within a transaction because I think and now I will just say em. I don't need this method. And here I have product repository dot is database connection healthy. And definitely this has to be changed to public because I'm calling it from the health check class. This has to be application scope. What if I say here, instead of repository, So I'm just trying to fix this, and now I've hit this, still showing down, syntax error parsing. So I will go to Apache Derby and we'll see some from the documentation, some quick start examples. So here So now now we got it working. Now we got say payment. Even better could be we create a dummy table and then call some query on that dummy table. But yes, this is also decent. Now let's implement this for the payment service. So I'll quit this health check. And then we come out of this project and come to payment, and then in the payment we'll add the microprofile health. So I will just enable in the Liberty this feature, microprofile health, and then I will go to MVN Liberty Dev. So let's see what does the health check provides by default without any implementation. Service is up. Started is up. Ready is up. And then finally live. So as such there are no checks. It will return up. In this catalog service, So now let's implement readiness check. Readiness check we have already implemented. Let's implement the liveness check. So yes, this I'm just renaming to let's say this I rename to, instead of readiness check. Okay, and now let me implement another class. This I will call payment service. Liveness check. Okay, again here I'll keep this application scoped, then I will say here this is liveness, and then I will have a method, let's say and I will say check available memory, right? And so we will also have a call method, call, and here I have to say implements health check, call, check available memory, and same logic. If let me take this entire method and here I will say check available memory instead, and this is boolean, and let's say we read the memory, and then we have some threshold, let's say the threshold could be 100 MB,